Hi guys, so today we are going to look at cumulative frequency diagrams and box plots. Now, both of these are ways of showing a set of data. Here is an example of a cumulative frequency diagram. It's a cumulative frequency graph. We plot it on axes and it's a graph. Now, generally, all cumulative frequency diagrams will take this sort of S shape. They could be slightly steeper, like this, and then flatten out like that, or you could have it where it is slightly shallower, but they will still generally make this S sort of shape. What you need to have on here is the data that you are measuring, so it might be something like the length of time or the weight of something, and then up here is your cumulative frequency. Now, cumulative frequency means a running total of the frequencies that you have. So that's a cumulative frequency diagram or a cumulative frequency graph. This is a diagram of a box plot. It might also be known as a box and whisker diagram. Now, this shows data with 5 distinct pieces of data from the data set. So what we've got at the bottom here is a scale. The scale will have numbers on in an example. These two lines represent the lowest value and the largest value. So I'm going to write the smallest value and the largest value. The line that's in the middle of your box, this is actually the median of the data, and obviously if you've got a set of data set out in a nice long line, remember to find the median, the data needs to be in order, smallest to largest, for you to be able to find your median. This value here, represented by this line, is your lower quartile. You might see me write it, whoops, not as U, as, lower quartile, like LQ. And this line here represents the upper quartile, which I think you've probably guessed now is represented by UQ. Now, it's really important that you understand these three things. Now, you will have come across median before. It's the middle of your data set. The lower quartile shows the first quarter of your data. Therefore, 3/4 of the data is above the lower quartile and 1/4 of the data is below the lower quartile. The upper quartile shows 3/4 of the data, and therefore anything below the lower quartile shows 3/4, and anything above the upper quartile shows 1/4. Now, there's something else that I need to tell you about here, and that is the interquartile range. Let me just write that down for you. Now, the interquartile range is calculated by doing the upper quartile minus the lower quartile. So let's say the upper quartile value here is 10 and the lower quartile here is 4. The interquartile range would be the 10, take away the 4, which would give me a low interquartile range of 6. Okay, so those are the bits of information that we need to know to understand our cumulative frequency diagrams and box plots. For the rest of the video, I'm going to show you a few examples for box plots, and then I'm going to show you a few examples for cumulative frequency diagrams. So, what I have got here is I've just got a box plot that I have printed off, and just to help show you what some questions might look like. Now, these would be basic 1-mark questions. So, what was the lowest number of points scored? This box plot shows information about points scored in a quiz. So I've got some context there in my blurb of the question. The lowest number of points scored is this line here. I need to look at my scale. This is 10 and this is 20. The difference between 10 and 20 is 10, and there are 5 little squares to get from 10 to 20. So if I just do that distance, which was 10, divided by 5, tells me that these lines go up in 2s. So that would be 12, 14, 16, 18 and 20. So my lowest value is going to be 12, 14, 16. What's the median number of points scored? So I go to the line that's in the middle of my box, and I know that the scale, each of these little squares goes up in 2s, and therefore this value here must be 42. So next question, what was the interquartile range of the points? So to find this, I need to find out what my lower quartile is. My lower quartile is 22, 24, 26, 28. And my upper quartile is 60. That was on a nice straight line there, 60. So my interquartile range is 60 minus 28. Therefore my interquartile range is 32. So that's how I read data off of a box plot. How about if I'm given a set of data that I need to draw a box plot for? So question, simply draw a box plot for the data listed below. So there were 5 bits of information that I needed to know. I needed to know my lowest value. Well, that's easy. I have put these all in order for us just for time. My lowest value is 23. My largest value is 38. Do make sure that the data is in order before you start writing this down for future questions, because sometimes in questions they don't write it all in order, and you could get this quite wrong. So my median value. Now we could cross one off from the end, and work our way into the middle. There is a slightly quicker way to do this. Now if I count how many pieces of data there are 11 pieces of data. So if I do 11 and I add 1 to it and divide that by 2, that gets me 12 divided by 2. It's the 6th value in the list. So 1, 2, 3, 4, 5, 6. My median value is 30. To find my lower quartile, I do 11 plus 1. The reason I'm adding 1 is because I've got a discrete set of data here, and therefore I need to just add 1 and then divide by 2 for the median. For quartile, I'm going to divide by 4. As I said earlier, it's to do with the quarters of the data. So if I divide that by 4, I get 12 divided by 4 gets me my 3rd value in the list. And so 1, 2, 3, my 3rd value is 28. Upper quartile is 11 plus 1 divided by 4. Well, that would get me my lower quartile. My upper quartile is the 3/4 of my way through my data. Remember I showed you here, lower quartile was 1/4 of the way through, upper quartile was 3/4 of the way through. So I need to do my quarter times by 3. We know that this came out as 3, times that by 3 gets me my 9th value in the list. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is 35. So now to put this onto a diagram. So I've just got some squared paper here, because you will have squared paper in your books. So I need to think of a scale. I know that I need to go from 23 all the way up to 38. So I will draw my scale on. Now obviously use a pencil please to draw diagrams, but I'm using pens just so that it will show up on the screen for you. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Have drawn my line slightly too long, but it doesn't matter because you will use a pencil and therefore you will be able to rub it out. And all we now need to do is we need to, I haven't actually given you any information about the data that I've given you there, so I can't really label on what it is, but if it was length of a leaf, let's say, I don't know why I've just chosen a leaf, but let's say it's the length of a leaf, I would just write under here length of a leaf and then whatever the unit is that it's been measured in. So my lowest value was 23, so 21, 22, 23, I'm going to draw myself a line. My largest value was 38, which is here. My median value is 30, so a line at 30. My lower quartile was 28, and my upper quartile was 35. Once I've got that, I can join up my quartiles with my box, as you saw in the other diagram. And then join on those whiskers there. And that is a box plot to represent the data that I had in my original question. Okay. Next example for you. So I have got the table shows information about the heights in centimetres of a group of year 11 girls. Let's straighten that up. Okay, so we've been given the least height, the median, the lower quartile, then we've been given the interquartile range and the range. So what I'm going to do is I'm going to use the range to help me find my largest value, because I know the range is the largest minus the smallest. So just by forming a little formula here, I know my range is 30, and I know that the largest minus the smallest, which is 145, gets me the range. So if I add 145 to both sides, I get 175 is my largest value. Okay, so now I've got my largest value. I also need to work out, what the upper quartile is. So I know that the interquartile range is the upper quartile minus the lower quartile. Filling in the information that I've got, my interquartile range is 12, and that's equal to the upper quartile, which I want to find out, minus my lower quartile, which is 155. So I need to add 155 to both sides. So I get 167 is my upper quartile. Okay, so now what I need to do is fill in the information on my scale. So I can't remember how long I've drawn this, but let's say I've started at 140. 1, 2, 3, let's go 145 just in case I haven't given myself enough space. 145. I'm going to go up in ones, but I'm going to count in 5. So 46, 47, 48, 49, 150, 51, 52, 53, 54, 55, 155, 6, 7, 58, 59, 60. 1, 2, 3, 4, 5, 165, 1, 2, 5, 170. I know my largest value is 175, so 1, 2, 3, 4, 5. I get 175 there. So good job I did start with the 145 there. I need to remember to put on my scale, so height in centimetres. And now I can just plot on the information. So my least height was 145. My largest value was 175. My median 163. Lower quartile 155. And my upper quartile, which I worked out here, 167. Again, joining up my upper quartile and my lower quartile in the box. And then adding my whiskers, joining my whiskers to the box. There we go. That is my box plot for that information. Okay, typical exam question I'm going to show you now, and that is where I'm having to compare two different box plots. Okay, so the box plots give information about the wages of a group of 16-year-old workers and a group of 18-year-old workers. So you can see the top box plot is for 16-year-old workers, and the bottom box plot is for the 18-year-old workers. First question, compare the distribution of the wages of year 16-year-old workers with the distribution of the wages of the 18-year-old workers. Now, when comparing box plots, you compare two things. You compare the medians and you also need to compare a measure of spread. Now, what I mean by that is compare the interquartile ranges of both. What is really, really important to ensure that you get all those 3 marks that it's saying, this is how you get 2 of the marks. To get the 3rd mark, it needs to be in context. And what I mean by in context is that I need to refer to 16-year-old workers getting an amount of wage and an 18-year-old workers getting an amount of wage. It's really, really important to get that final mark, that it needs to be in context to what the information is in the box plot. So comparing the medians, so we can look at the values here for the 16-year-old workers and the 18-year-old workers. Now I need to work out what the scale goes up in. So I have a difference of 50 across 10 squares. Therefore each little square is going to go up in 5, because 50 divided by 10 gets me 5. So looking at the median for my 16-year-old workers, I'm just going to get my ruler and measure down to help me here. So that's 150. We know it goes up in 5, so 155, 160, 65, 70, 75, 80. So the median for the 16-year-olds is 180, and then the median for the 18-year-olds, which I'm measuring here, is what have we got? We've got here 200. Where's the measure of 200? 200, 5, 10, 15, 20, 25, 30, 35, 40. So we've got 240 there. Bear me 2 seconds, I'm just going to plug my laptop in because it's running out of battery. Not very professional, I do apologise. Hopefully that will be on charge now and you won't run out. Sorry about that. Okay, so comparing the medians then. So we can say the median wage of 16-year-olds is £180, which is lower than the median wage of 18-year-olds, which is £240. So we have compared the medians in context because I have mentioned about the wage of the 16-year-olds median compared to the 18-year-olds median, and I have said that 16-year-olds is lower, so I have compared them. So I've compared the medians. I now need to compare the measure of spread by looking at the interquartile range. So I need to find the interquartile range. I have worked these out already for you, just for a bit of ease and a bit of quickness. So for the 16-year-olds, let's move this up so you can see what I'm doing here. So 16-year-olds, my upper quartile is 210 and my lower quartile is 130. So the interquartile range for that is 80. For the 18-year-olds, my upper quartile, which I find the value from here, is 280, and I subtract the lower quartile, which is 210, which gets me an interquartile range of 70. I can then write my statement about the interquartile range. The interquartile range for the 16-year-olds is larger than the interquartile range for the 18-year-olds. So that is what is required for comparing two box plots. So the next part of the question says there are 200 workers who are 16 years old. So this box plot represents 16 workers. Work out an estimate for the number of these workers whose wages are £130 or more. So I need to find out where £130 is. So £130 is this value here, which conveniently is the lower quartile. So £130 is the lower quartile for the 16-year-olds. So we know that those that have more than £130 must be 3/4 of the data, because this is the lower quartile, this is the first quarter, and then therefore the leftover must be the other 3/4. So I need to find 3/4 of the total amount of people represented in that box plot, which was 200. So 1/4 of 200 is 50. So 3/4 must be 150. So the answer to this question is 150. Okay, so we are done looking at our box plot examples. What I'm now going to do is to show you the cumulative frequency graphs. So here I have got a question. The table shows the number of minutes shoppers spent queuing to get into the supermarket on Saturday. I think that's fairly relevant at the moment considering our situations. So here I have got a graph, number of minutes. So this is saying that the time between 0 and 10 minutes, there were 2 people. Between 10 and 20 minutes, 6 people. 20 to 30 minutes, 10 people, etc. Now, I know that at the moment we've just got frequency. What you're going to need to do is to add a column on for cumulative. Frequency. So, what I said at the beginning of this video is cumulative frequency, or what did I? Can't remember. Cumulative frequency is a running total of the frequencies that you have got. So between 0 and 10, I've got a frequency of 2. Then between 0 and then 20, I've then got a total of 8. All I have done is added 6 to that 2. Then between 0 and 30, I've already got that 8. I now need to add 10 to it, so I get 18. Between 0 and 40, I need to add 9 to my 18, so I get 27. And then between 0 and 50, all of the data, I add 3 to that 27, so I get 30. So just to go back through that, just to help you really understand what I've done, the first one is always going to be that value there. Then to find my next value in my cumulative frequency, I add this value to this value. So 2 add 6 is 8. Then to find this value, I added this value to that value. So 10 plus 8 is 18. And then 9 plus 18 got me 27. And then 3 plus 27 got me 30. So now I've got that information, I can plot that onto my cumulative frequency graph. Again, I've already drawn this out just for a little bit of ease. So on the bottom here, what I need to do is I need to make sure that I label what this is, and this was time in minutes. And then up here, I'm going to have cumulative frequency. Okay, so now I've got my axes labelled. What I need to do is I need to plot the information on. So here's the data. Between 0 and 10, the cumulative frequency was 2. So what I'm going to do is I'm going to find 10 on my graph, and I always plot it at the end number here. So 10, the cumulative frequency is 2. Then at 20, the cumulative frequency is 8. So 5, 6, 7, 8. And the next one, I plot at 30, and then it's 18. So 16, 17, 18, 30, that's 18, 40 is 27, and 50 is 30. I'm just going to plot that on 40 at 27, and 50 is then at 30. And then hopefully you can see that I have got that S shape for my graph. All I need to do is to then just join it up with a nice smooth curve. And there is my cumulative frequency for the data that we started off with. Okay, so my next example is one where I've got a cumulative frequency diagram already drawn out, and I'm having to read information from it. The question says, work out an estimate for the number of the students with a height greater than 160 centimetres. So what I'm going to do is I'm going to read off of the graph where 160 centimetres is, all the way up to where it hits the graph. Hopefully you can see that. Perfect. And then I just need to read across what that value is there. So nice easy scale, goes up in ones. This value here must be 48. Now I need to be careful, I need to read the question carefully here. Work out an estimate for the number of these students with a height greater than 160. So we know that 48 students have a height up to 160. We need to work out how many there is in this little bit here. We know that the total is 60, and we know that this value here is 48. So if I subtract 48 from the 60, it's going to be 12 students who have a height greater than 160 centimetres. So to do that, I read up from 160 to find out what the cumulative frequency is, and then to find out the amount that would be in this section, I looked at the total, which was 60, and then subtracted the 48, which gave me a difference of 12. Okay, one final example. This is a past GCSE question that I have found for you. The cumulative frequency graph shows information about heights of some hollyhock plants. Find an estimate for the median height. Okay, so to do this, I need to work out what my median value is. So, looking at the data, cumulative frequency, it goes up beyond 80. I need to work out what this is. So on my scale, each of these must be 2, because that's 62, 64, 66, 68, 70, 72, 74, 76, 78, 80. So each of these little squares must be 2. So to work out the total frequency, I'm going to have, that's 80, 82, 84, 86, 88. So I have a total frequency of 88. So to find the median value, I'm going to do 88 and divide it by 2. The reason I'm not adding 1 this time is because I have got some continuous data in the form of my graph, and therefore I just need to take the value of what I've got on the graph and then divide that by 2. So that's going to get me my 44th value. So to read my 44th value, I need to find my 44th value on the graph. So here's 40, here's 42, this must be my 44th value, and therefore I read across and down. Now this must be 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. So that value there must be 83. So my median height is 83 centimetres. Hopefully you can see what I did there. I do realise it wasn't on the screen, sorry about that. I read off 44 on my graph. I read across to my line where I hit 44 on my line. I then read down, which got me a value of 83 there. To find the interquartile range, what I need to do is to find my lower quartile and my upper quartile. So my lower quartile is going to be 88 divided by 4. So that gets me my 22nd value. My 22nd value I need to read from the graph. So there's 20 and there's 22. So there's 22, and reading down is that value there. That must be 70, 75, 67, 77.5. So my lower quartile, this 22nd value, was 77.5 centimetres. Remember the question asked for my interquartile range, and therefore I need to find my upper quartile, which is going to be 88 divided by 4 multiplied by 3 is going to get me my 66th value. So from my graph, I can label that as lower quartile. 66th value, so that's 62.46. Reading down from there, that was 83, 4, 5, 6, 7, so that must be 87. So my upper quartile there was 87 centimetres. So my interquartile range is my upper quartile, which was 87, minus my lower quartile, which was 77.5. So I get 9.5 centimetres as my interquartile range. Now, finally on this question, it says find an estimate for the number of hollyhock plants taller than 90. Very, very similar to the question that I did on the previous example. I read up from where 90 is. I read across to see what value that is. So that value must be 78 because they go up in 2, so that's 70, so 2, 4, 6, 8. We know that the total frequency was 88, therefore the plants taller than 90 is going to be our total of 88 minus that value of 78, which is 10. Okay, now just before I finish off, I just want to tell you that you can use a cumulative frequency graph to find or to draw a box plot. So as long as the question gives you the lowest value and the largest value, so let's say the smallest value here is 60, let's just say, so the smallest is 60, and I'm going to say the largest is 100. Now we don't always just assume that it is these values here and here, but just for the purpose of this example to show you how this can be done, I'm just using those values there. I've got the smallest and largest. You've just seen how I've worked out the lower quartile, the median and the upper quartile, and those are the 5 pieces of information that you've got to then draw yourself your box plots. Obviously to scale, which I'm not going to do because I've done far too many and the video's gone on far too long, and you've done really well to listen all this much, so well done, and hopefully you can now be a pro at cumulative frequency graphs and box plots.